Good morning, students. So this is the second class of some basic concepts of chemistry, that is the bridge course. Okay. So in the last class we discussed about what? The classification of matter. How the matter is classified. So physically they are classified as what? Solids, liquids, gases and plasma state. And chemically they are classified as mixtures and the pure substances. That mixture is further classified into homogeneous mixture and a heterogeneous mixture. And still last class we discussed about the homogeneous and the heterogeneous mixture. So in today's class we will go with pure substances. Pure substances. Okay, so this pure substance again classified into what? Elements and compounds. Elements and compounds. And these elements further classified as metals, non-metals and metalloids. Okay, these again further classified as organic compound and inorganic compound. Students, I hope you get. So listen, pure substances, I told you chemical classification, mixtures are there, pure substance are there. This pure substance means that is further classified into elements and the compounds. Again they are further classified into metal, non-metal, metalloids, and organic compound and inorganic compound. So we will discuss one by one. So what are pure substances? So you know what are mixture? The mixture of two or more compounds are called as what? Pure mixtures. Okay. So what are pure substances means? It consists of only one type of atom or a molecule. For example, water is there. Example I write. H2 is there. N2 is there. Helium is there. H2O is there. Okay. So these are all example for what? Pure substances. Here atom is there, here molecules are there. Okay, so these pure substances, again elements can be classified into different types, I will say. So before that I will explain students, the pure substances are made up of only one type of atom or a molecule. It may be an atom, it may be a molecule, but it is of only one type. So in that, elements are there, compounds are there. Okay, so elements means only one type of atoms combined with each other to form elements. Only one type of atoms. And right here, one type of atoms. So this is example for element. This is also example for element. Okay, this is also example for element. So these are all what? Pure substances that is made up of only one type of atoms or molecules. In that, students, types are there. One is monoatomic, diatomic and triatomic. Okay, so in this elements, homoatomic or homomolecule are also there. Homoatomic and heteroatomic. So the elements I told, they are made up of only one type of atoms. Okay, so in that also homoatomic is there, heteroatomic is there. Okay, so here what happens in that homoatomic again mono, di, tri is there. Example for the students, homoatomic, helium, neon, carbon, etc. Diatomic means N2, here am I right? Silver, gold. So this is N2, O2, H2, X2. X2 means halogens. For triatomic, ozone. That is O3. This is O3 molecule. This is monoatomic, diatomic and triatomic. You know what is mono, di, tri represents number of atoms present in the substance or a compound. Mono means one atom, di means two atom, tri means three atom. Okay, so this is all about what elements. What is heteroatomic means? Heteroatomic means made up of two or more different atoms. For example, this is HCl is there, H2O is there, and HNO3 is there. Okay, here H is different, Cl is different, H is different, O is different, this H and O is different. So these type of atom or molecules are called as, or elements are called as what? Heteroatomic molecules. Understood? Okay, I hope you understood. So this is homoatomic, this is heteroatomic. Hetero means different, homo means same. Okay. So students, another one thing is what we are going to discuss now. So I said few substances, elements are there. In that elements based on the atoms, they classified like homoatomic and heteroatomic. Now in that different metals are there, non-metals are there, and metalloids are there. So what are metals, metalloids and non-metals? You are well known about that. Metals means based on conductivity we want to say means metals are good conductors of heat and electricity. Okay. So in the periodic table I will say, I thought you are well known about the periodic table. This is S black, this is P black, this is T, and this is F black. Representation of what? So this is the representation of general form of the periodic table. This is S black, P black, T black and F black. So students, whatever the elements present in S and D black are almost metals. Okay, so whatever elements present in S and D block are almost what? Metals. Here, so listen, boron is there, carbon, nitrogen, oxygen, fluorine, here. Here, from here I am telling, this is exact manner. So from here, okay, there is a step in this manner. Okay, so in the P block, this part is all what? Metalloids. This part is what? Metalloids. This one is non-metals. Okay, so in the periodic table, the extreme left of the elements, whatever the present, they act as what? Metals. Extreme right, they are non-metals. In the P block, the zigzag type steps like one zigzag manner, separation is there. You may see clearly in the periodic table if you observe students. Those are called as what? Metalloids. Okay, those metalloids behaves like metals as well as non-metal. So I will explain the characteristics of metals, non-metals and metalloids. Okay, here if we consider metals, metals are soft in nature. Metals are soft in nature. Okay, and they are good conductors of heat and electricity. They are good conductors of heat and electricity, and they have the property malleability and ductility. Malleability and ductility. Next, soft in nature, good conductors, malleability and ductility have high melting and boiling point. So they are soft in nature, they are good conductors of heat and electricity, they are malleable and ductile in nature, and high melting point and their boiling. So students here, and they have lustrous in nature. Lustrous means shining. They have the shining surfaces. Okay. So students, what is this malleability and ductility means? You know, I will give one example. The aluminium sheets are coated over what? That sweet. Okay, while you packing the sweet, there is a silver-like color layer is there on the sweet what we used to eat like burfis in the bakeries. The silver color, that coating is what? Aluminium. That aluminium is made up into what? A thin sheets. If any metal can be made it into a thin sheets, that is called as malleability. Okay, what is ductility means? If we get an electric wire, in that electric wire we can assume a brown color small wires, a metal wires. I hope you understood. In an electrical wire, if you remove the outer covering of the layer, so then we will get inside that we will get a thin black color or a brown color or copper color like threads. Okay, small strings. So that is called as what? The if the metal is made into what? A small threads, then it is called as ductility. So why the metals have malleability and ductility property means they are very soft in nature. So they have the right melting point and boiling point. So we can easily make it into a thin sheets as well as thin wires like threads. I hope you understood. This malleability means the property of a metal made it into thin sheets. Ductility means property of a non-metal which made into a what? Thin threads. Okay. So in this, non-metals are there. Okay. So non-metals means of course they are hard in nature. They are exactly opposite to metal students. They are hard in nature and they are bad conductors of electricity. Bad conductors of electricity and they don't have malleability and ductility, and they have low melting point, boiling point, and they are not lustrous. They are not lustrous. So they are exactly opposite to what? That metals. So metals are soft in nature means non-metals are hard in nature. They are good conductors and they are bad conductors. They are malleability and ductility and they don't have malleability and ductility property. These metals are high melting and boiling point, but metals are low melting and boiling point. Not that much low compared to metals, they have low melting and boiling point. Next, they are lustrous in nature and they are non-lustrous in nature. So when we come to metalloids students, so metalloids means they are neither on nor soft. So their all properties are in between metals and non-metals. For example, this is hard means metalloids are neither on nor soft. Here the good conductors, here bad conductors means sometimes they are good conductors, sometimes they are bad conductors. I hope you understood. The metalloids are, the conductivity of the metalloids are between metals and non-metals means sometimes they act as a conductor, sometimes they act as a non-conductor or a bad conductor. So they have malleability and ductility property means semiconductors shows some amount of that property. Sometimes some amount they don't show some amount of the malleability and ductility. Okay, so they have a melting point and low melting point and boiling point means the boiling point of the metalloids is in between the boiling point of metals and also boiling point of the non-metals. Okay, they are lustrous in nature, they are non-lustrous. Of course, the metalloids are also non-lustrous in nature. This is all about the elements. Then we will come to what? Compounds. Okay, then we will come to compounds. Organic compound is there, inorganic compound is there. So students, what is organic compound? I think in the chapter carbon and its compounds of 10th chemistry, you are well known carbon as catenation property. Carbon as catenation property. So what is meant by that catenation? What is meant by that catenation? Catenation means the ability of the atom bonded to the same atom to form a long chain. Okay, so carbon is one atom. It has the capacity to bond it to the other carbon to form a long chain. Okay, we don't know how many carbon atoms are present. So, how many carbon atoms can have the capacity to bond into the other carbon atom? Now, the maximum number of carbon atoms present in the higher proteins is C300. 300 carbon atoms are continually bonded with each other to form a macromolecule. Macro means very big, 10 to the power 6. Okay, so students here, this because of the high catenation property of the carbon, it forms so many compounds. So that's why what is organic compound means carbon and its compounds. Alright, organic compounds nothing but hydrocarbons. Carbon and hydrogen compounds. Okay, so for this example, students, alkanes are there, alkenes are there, and alkynes are there. Alkanes, and alkynes. Okay, so in this inorganic compound means they are other than carbon and its compounds. For example, here we are only studying carbon and its compounds they are derived from organic compounds are derived from living organisms. Okay, so these are other living things. The compounds which are derived from non-living things are called as what? Okay, so inorganic compounds are derived from what? Non-living things. So they are called as what? Inorganic, non-organic compounds. So one which are derived from the living things, they are called as hydrocarbons. For example, formic acid is there. Formic acid is there, which is derived from what? Red hand. Red hand. So if red hand bites us means we will feel what? Some amount of burning sensation. Okay. So that is because of what? Presence of the formic acid. So formic acid is derived from red hand. So formic acid is an organic compound. Similarly, acetic acid, that is called as vinegar. Okay. Next, tartaric acid. Okay, next, presenting citric acid, present in what? Lemon. Okay, you know plants is also living things. Next, oxalic acid, that is present in tomato. Okay, so these are all derived from what? The living things, so they are called as organic compounds. And these are derived from non-living things, for example, HCl, okay, HNO3, H2SO4, okay, and next NaCl, MgCl2, etc. So here, these are all available. NaCl, we know that NaCl is the salt which we are used in our daily life, like a Tata salt, you know, Ashirwad, you know. Okay, those are all what? NaCl salts. So these NaCl salts can be synthesized from where? By using seawater. Seawater is the main source of this NaCl. Okay, so here students, so these are available from seawater. You know the seawater is a non-living thing. It never affected by anything. Okay. So these are derived from the non-living things and they are called as inorganic compounds. And these are organic compounds. So this is all about what? Pure substances. Okay. So the next one is Dalton's atomic AE. So here we are discussing atoms, molecules. Atoms, molecules means where these atoms and where these molecules can come. Okay. So here, next thing we are going to discuss is the if the atom is there, atom consists of the number of molecules and the number of molecules where they come from, how it is classified as a molecule or an atom. So that is all comes under what? That okay, alright. Atom, molecule, atomic mass, molecular mass. Now we will discuss these things. What is atom? What is molecule? What is atomic mass? What is molecular mass? So to study this student, first thing we are going to do is Dalton's atomic theory. Dalton's atomic theory. So Dalton was a scientist who studied the structure of atom and he gave some postulates regarding the atom. So okay, so listen. What is atom means? Atom is smallest indivisible particle of matter. Okay, smallest indivisible particle of matter is called as what? Atom. Okay, so this atom as atoms as identical mass, identical size, identical volume, etc. Completely they have identical overall properties. Okay, I write completely properties here. So atoms has identical properties. Especially here, atoms of same element. Atoms of same element has identical properties. For example, why I told this? H2 is there, O2 is there. Hydrogen is the atom, oxygen is the atom. So here, if two hydrogen atoms are there, this one, both have the identical properties because atoms of the same element. Here, hydrogen has different character and the properties, oxygen has different in character and properties. We cannot compare the atoms of the one atom with the other. Okay, so atoms of the same element as identical properties. Okay, so next, atoms neither created nor destroyed. Okay, so atoms neither be created nor be destroyed. So they rearrange to give different compounds or elements in the chemical reaction. Okay, students. So this is all about what? For example, if I write NaCl plus H2O, we will get NaOH plus HCl. Okay, NaCl plus H2O, then we will get NaCl or you take this NaOH plus HCl. When acid reacts with base, it forms salt and water. NaCl plus water. You are well known about this, students. Okay, this reaction is, you are quite known about this reaction. NaOH plus HCl. This is base, react with acid, gives salt and water. Correct? So here what happens? Na is one atom, O is one atom, H is one atom, Cl is one atom. Here rearrangement of atoms takes place. The rearrange to give different compounds and the chemical reaction. So your Na is there, along with Na, OH is there, but here Na in the product replaced by what? Cl. So the rearrangement of the atoms takes place to give different compounds. So listen, this character is this character is acid, its character is salt. Okay, this is the last one. Then atoms neither be created nor be destroyed. Here, in the left hand side, one sodium is there, one oxygen is there, two hydrogen is there, one Cl is there. Correct? In the here also, one sodium, one Cl, two hydrogen, one oxygen. So in the both the left hand side and right hand side, means reactant side and product side, the atoms are same. Okay, here one Na is there, here also one Na. Here one oxygen is there, here also one oxygen. Here two hydrogen, here also two hydrogen. Here one Cl, here also one Cl. Okay, so students, the atoms neither be created nor be destroyed, but they rearrange with each other to form a different compound. So here in the reaction, so this shows what? The law of conservation of mass. Okay, that shows law of conservation of mass. Okay, next one is the atoms has their identical properties, as I told. The atoms has its own identical property. If sodium atom is there, one sodium atom is there, that is a neutral molecule. Then if one atom is there and 1,000 atoms are there, all the atoms shows the same properties like mass, melting point, boiling point, thermal conductivity. So whatever the property is shown by the one atom, that is shown by the all the 1,000 atoms. Okay. Next, smallest individual particle of matter. You know, matter as so atoms are there. So in that atom, it is the smallest part. But in that proton, electron, neutrons are there, but they are indivisible. I told the smallest indivisible particle. Okay, it cannot be divisible. If matter is there, for example, N2 can divide as N and N. So that is individual atom. But N cannot be divided as protons, neutrons and electrons. So that's why the smallest individual particle of the matter is called as atom. So this is what about Dalton's atomic theory. Then what is molecule means? Two or more atoms combine together to form a molecule. For example, sodium is atom, N2 is molecule. Okay? N2, O2, H2 are molecules. The sodium, lithium, silver, gold are atoms. Okay? Helium is also an atom. If only one atom is there, one proportion is there, or one atom is there, that is called as atom. If two or more atoms combine with each other, called as what? Molecules. Then we will discuss what is atomic mass and the molecular mass. So first I write the formula of atomic mass and the molecular mass, students. So while we start and explain the atomic theory, at that time only one well-known element is carbon 12 iso2. Okay, so at that time the well-known isotope element is carbon 12 iso2. Okay, so this atomic mass as well as molecular mass both are compared with what? This carbon 12 isotope. For example, I'll write here atomic mass is equal to average atomic mass of one atom, or average atomic mass of atom divided by 1 by 12 of carbon 12 mass of 1 by 12 of carbon 12 isotope. Okay, mass of 1 by 12 of carbon 12 isotope. So next, molecular mass means average mass of a molecule divided by mass of 1 by 12 of mass of carbon 12 isotope. So this is the formula. What it means, students? For example, we have atomic mass of oxygen is 16. Okay, what it means? What is this atomic mass gives? So the atomic mass, this shows the atomic mass of oxygen is 16 times of carbon 12 isotope. 16 times of carbon 12 isotope. So here molecular mass of oxygen is 32. Okay, so this means the molecular mass of oxygen is 32 times of C12 isotope. 32 times of mass of C12 isotope. I hope you understood. So this is what the atomic mass and the molecular mass. So atomic mass means the atomic mass of oxygen is 16 times of C12 isotope, and this Molecular mass means the molecular mass of oxygen is 32 times of the C12 isotope. So at that time we have only the well-known isotope is the carbon 12. So each and every atom, their atomic mass and molecular mass is calculated by comparing them with the carbon 12 isotope. So here the average atomic mass of atom by 1 by 12 of carbon 12 isotope. Here for molecular mass also same formula. But now students, you can easily calculate the molecular mass and atomic mass by knowing their number of protons, neutrons and electrons. Okay, so then next one is atomic number and okay. So the next one is atomic number. What is atomic number? The number of protons in an atom is called as atomic number, represented by Z. Okay. Another one thing, number of proton is equal to number of electrons. You have to remember. So the next one is mass number. What is this mass number? The sum of total number of protons and neutrons in the atom is called as mass number. Atomic number means the number of protons in an atom that is represented by Z, and number of protons is equal to number of electrons in the, especially this is when in the neutral atom with the zero charge. Okay, next, this mass number means the sum of total number of protons and neutrons in the atom is called as that mass number and represented by A. Okay, so the general representation of the element is, students, X is the element, A is the atomic mass, Z is the atomic number. It can be represented like this or like this. Okay, this is atomic number means number of protons plus neutron. This is number of protons. Okay, so this is all about the atomic number and the mass number. So in the tomorrow's class, we will discuss how atomic number, how the number of protons and electrons are calculated in an atom, how the mass number, and using the atomic number, how the molecular mass is calculated. Okay, thank you.